Good evening, wonderful algebra students. We are beginning a new chapter. We are in chapter 9, and we are beginning with section 9-1, and we are going to be talking all about quadratics and parabolas in this chapter, and you will know what that means after we talk about definitions and all that stuff. So let's jump right in. I'd like for you to be able to identify quadratic functions and their graphs and properties by the end of these notes. So let's talk about some definitions. What on earth is a quadratic function? So a quadratic function is a function that can be written in the form ax squared plus bx plus c. That's the standard form of this. And essentially, what you have to have for a quadratic function, you have to have an x squared. So I'm just going to say, just in parentheses, you always have an x squared somewhere in the expression. Okay, or the equation, I should say. So now let's just talk about a couple things that we know about quadratics. So it says the simplest quadratic function is f of x is equal to x squared or y equals x squared. So we can complicate equations a whole lot, or we can make them very simple. The simplest form of a certain type of problem is something called the parent function. And this is what the parent function looks like for a quadratic. Now, every single quadratic function, like I said, is going to have an x squared in it, and that's actually going to be the highest exponent value. But not only that, it's always going to make a U-shaped curve. A U-shaped curve is a parabola. So just like we know y equals mx plus b always makes a line, well, now we can say, oh, well, if my problem has an x squared in it, it's always going to make a U-shaped curve. Now, this U-shaped curve is going to have a line in the middle of it where it is perfectly reflected on either side. It's going to match up, or when you fold along that line, it is perfectly aligned. So this is something called the line of symmetry. Now like I said, there's lots of ways that we can describe parabolas, so and different points on them as well. So if we have the highest or lowest point of a parabola, that's called the vertex. So notice these two graphs right here. We have a parabola going upward and a parabola going downwards. Notice they both have one big curve and they both look like U's. This point right here where it changes directions, the highest point or the lowest point is the vertex. Now the vertex is always going to fall on that line of symmetry or the axis of symmetry. Maybe I should put it like that as well. I'll put it axis of symmetry. My apologies. So the axis of symmetry is perfectly down the center of the parabola. But there's some other things that we can describe in the parabola. Which direction is it opening up? So if a is greater than 0, or in other words, if the first number in front of x squared is positive, then the vertex is the minimum, and the parabola will open upward. But what if it goes in the other direction? For example, what if there's a negative number in front of x squared? Well, if there's a negative number in front of x squared, then the vertex is going to be a maximum, and the parabola will open downward. So this is an example of a parabola opening down right here. And this point way up here is called a maximum because it is the highest point that it reaches. This one, on the other hand, is opening upwards. It's to the top. The lowest point is a minimum. So let's just identify some vertices here. So we want to identify the vertex in each graph. And so that's going to be where the graph changes direction or the highest or lowest point. So in this, and then we're going to determine if it's a maximum or a minimum. So the vertex on this graph is right here. So what is that coordinate? Well, it's on the x-axis or the y-axis, so we know the x value is 0. And then we go up 1, 2, 3, so the value is at 0, 3. And then is this a maximum or minimum? Is it at the very tip top of the graph or the very bottom of the graph? This is at the very tip top, so this is going to be a maximum. Looking at this example, our vertex is in a different spot now. It's right here. That coordinate is at 1, -1. But is this coordinate at the very tip top of the graph or very bottom of the graph? It's going to be at the very bottom, so this one is a minimum. Let's work on just graphing these today. You're going to be exposed to more and more patterns, so I know this feels like a lot of information and just describing these graphs, and it's totally new. It's okay, we're going to take it one piece at a time, and we're just going to talk about graphing. So it says graphing quadratic equations in the form ax squared plus c, which is the simplest form that we're going to be doing right now. And it says, make a table and graph the quadratic function. So we've made tables like this in the past, and all we're going to do is put in an x, put in a y, and put in our function rule in the middle. So our function rule is y is equal to 3x squared. I'm just going to say 3x squared like that, just for space. Now what you're going to want to do is choose some points for x. Don't make them super hard, because that'll be, annoying. And we also want them to fit on the graph. So I'm going to choose numbers close to 0. And I have 5 points to work with, so I'm going to start with 0 in the middle, and then go 1, 2, and -1, -2. So that makes it kind of nice if I start with an easy point. And like I said, as we progress, you'll be taught more patterns and more strategy for how to do more complicated ones. But right now, we're just starting with the simplest type, so that's why we're able to set it up like this. Okay, so now I'm going to take my x value and substitute it in for my x point in my expression. So this is going to be 3 times -2 squared. This one is 3 times -1 squared. 3 times 0 squared. 3 times 1 squared, and 3 times 2 squared. Now we need to follow order of operations. So that means exponents and then multiplication. So I'm going to write PEMDAS up here just to remind you guys of that. We need to take care of parentheses and exponents. There aren't really any, I know you see parentheses, but it's not really a grouping symbol here. It's used for multiplication. So now let's go to exponents. So I need to take this -2 and multiply it by itself. So -2 squared. What is -2 times -2? Well, -2 times -2 is 4. So this is becoming 3 times 4. Let's go to the next one. -1 times -1. Is +1. So this becomes 3 times 1. 0 times 0 is 0. So I've got 3 times 0. 1 times 1 is 1. 2 times 2 is 4. So all I did was rewrite the exponent part. Now I'm ready to do the multiplication, which is the 3 times that new number. So 3 times 4 is 12. 3 times 1 is 3. 3 times 0 is 0. 3 times 1 is 3. 3 times 4 is 12. Alrighty, so now I have 5 coordinates that I can plot on my graph to see if I can find a pattern. So I'm at -2, 12. I'm going to go back 2 and up 12. 2, 4, 6, 8, 10. Wow, it barely fits. 12. Awesome. But I also know I need to go over 2, +12, so I can just go ahead and put that point right there. And then I go back 1, up 3. So back 1, 1, 2, 3. Or I can go over 1, up 3. So I can do that. And then I also have a coordinate at 0, 0. Now you might be thinking, where am I getting these points? Remember, this is my x and this is my y. So if I need to write them over to the side as like -2, 12, -1, 3, 0, 0, 1, 3, and 2, 12, then you can. That is more than fine. I'm just pulling them straight out of my table. So what we have here, we are going to now connect the coordinates to form our U shape, because remember, parabolas are always going to be that U shape. So now this is kind of just your best job that you can do at it, because it is a little, it's not necessarily easy to do this. So there is our parabola now. Now we do want to identify the domain and range. We talked about domain and range a long time ago as well, so I'm just going to remind you, domain are your x values. Range are your y values. So x goes left and right, y goes up and down. So I'm actually going to put arrows, so left and right, up and down. Looking at this from left to right at your graph, this is a pretty steep line, but notice how it's slightly angled to the left. So this guy right here, it's going to keep going and keep going and keep going, and it's going to keep going to the left. And then this line right here is going to keep barely going to the right. So the domain is going to be all real numbers, because anything to the left and anything to the right is going to be accounted for eventually. The range, on the other hand, or the y values, is not going to all be accounted for. Notice how this graph is not going below the y-axis, or the x-axis. I'm sorry about that, you guys. Goodness gracious. So the y value is not going to go past 0. It's not going to go below 0, but the y will keep going up, 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 up. So all we have to say is y is going to be greater than or equal to 0. Let's graph another one to get some practice in here. It says make a table and graph the quadratic function. Y is equal to -1/2 x squared plus 1, then identify the domain and range. All right, easy enough, we can do that. So I'm just going to put in my x and my y and then my rules. So I've got -1/2 x squared plus 1. I'm going to go ahead and put 0 in the middle again, because we're allowed to, this is a special type of quadratic function where it's going to follow a rule where the y-axis is the axis of symmetry. You'll learn more patterns in the future, like I said. Now, we might not necessarily want to choose the numbers 1 and 2 this time, because look at what I'm going to have to multiply this by. I'm going to have to multiply it by 1/2. So maybe choosing even numbers only could be really helpful. So I'm going to choose -2 and -4 and +2, +4. Now the reason I am doing that is because I see this 1/2, and when I multiply by 1/2, I'm actually dividing by 2. So I just want to avoid fractions and decimals, basically. So that's all I'm doing. So now I'm going to take these x values that I came up with and put them in for my x spot. So I have -1/2 times -4 squared plus 1. -1/2 times -2 squared plus 1. -1/2 times 0 squared plus 1. -1/2 times 2 squared plus 1. -1/2 times 4 squared plus 1. Still following orders of operation. So PEMDAS. We don't have any parentheses we need to worry about, but we do have exponents. So this exponent right here, I'll just work this out to the side so you can see it. -4 times -4 is 16. So now I have this equation, -1/2 times 16 plus 1. That was my first step of squaring the -4. So -4 times -4 is 16. That's where this part came. And then I carried over my -1/2 and I carried over my 1. Now I'm doing multiplication. So I took care of exponents. Now I'm doing multiplication. -1/2 times 16 is equal to -8. But I still have that plus 1, so I want to put that on there. -8 plus 1 is -7. That is my y value. So let's do that again for this term, just so you can see it one more time. So here I have -2 times -2. I'm starting with that because that's the exponent, and I'm just following order of operations. So -2 times -2, this is going to be -1/2 times 4, because a negative times a negative is a positive, and then plus 1. Okay, now I'm doing multiplication. -1/2 times 4 is -2 plus 1. Well, -2 plus 1 is going to be -1. Did I do that right? 4 times -2 divided by 2. Yes. I think I just did it wrong on my answer sheet over here. So, okay. Now I'm going to do the rest a little bit quicker. So 0 squared is 0 times -1/2 is 0, and then 0 plus 1 is 1. Here we have 4 times -1/2, which is -2. -2 plus 1 is -1. And then this one is going to get me -7. 4 times 4 is 16. 16 times -1/2 is -8. Plus 1 is -7. Now we have our coordinates. Let's plot them over here. So I have -4, -7. So back 4. 1, 2, 3, 4. Down 7. 1, 2, 3, 4, 5, 6, 7. Back 2, down 1. And then over none, up 1. And then this is over 2, down 1. And this is over 4, down 7. 1, 2, 3, 4, 5, 6, 7. There we go. So this time the U shape is kind of pointing downwards, and that's okay. So just do your best to connect your points. Let's talk about domain and range. Domain is left and right. So how far left and how far right is this going to go? It's going to be all real numbers because it's going to keep spreading over time. The range, on the other hand, does have a maximum. The range is not going to go past this 1 right here. So I'm going to say y is less than or equal to 1 for our range. Now for our last example in our notes, we are going to do that tomorrow in class. So just keep that handy and ready to go. I hope you have a wonderful night, and please bring questions to me tomorrow if you have any.